Hello, and thank you for joining us for the AMS webinar with FARO. My name is Nick Holt. I'm the editor of Automotive Manufacturing Solutions magazine. Today, Keith Noble, Sales Support Engineer for the Laser Tracker team in FARO, UK, will be introducing the brand new FARO Laser Tracker, designed to give you fast and accurate remote measurements. Keith will be demonstrating how this new piece of equipment is the most flexible way to complete measurement jobs faster in tough environments, while maintaining high accuracy, and move easily between job sites. Customers around the world are using the FARO Tracker to solve their everyday measurement challenges, as well as their most complex problems that simply weren't previously possible. Keith has been working in metrology for almost 15 years and has spent over 10 years of that time working with laser trackers. His career started with Comau Systems in 1998, where he was using laser trackers to set automotive tooling. In 2003, he joined JCB as a quality engineer using FARO measuring arms, before joining FARO in 2006. Now, before I pass over to him, I'd like to remind all of the attendees to draft some questions which Keith will answer in the question and answer session following his presentation. You can ask these questions by typing them into the box in the lower right-hand side of your screen. I can also confirm that Keith will be seeking your views during the session via a poll. So do keep listening and watching for your chance to give him some feedback. If you happen to experience any technical issues during the session, please do type these into the Q&A box and our team will do their best to sort these out for you. We hope you find the webinar stimulating and informative. I'll now hand you over to Keith to begin his presentation. Thank you.
Thank you, Nick, and very good afternoon to everybody, and welcome to this presentation on the new Laser Tracker Vantage, which is a fast, accurate and remote measurement system. So the goal of this webinar is to introduce you to a flexible way to complete your measurement jobs faster, to measure in tough environments while maintaining the highest accuracies, and also to be able to easily move between site to site. So before we talk about the product in specifics, I'd like to give you a little bit of history about FARO. So our company started in 1982, around 30 years ago, by two gentlemen called Greg Fraser and Simon Rabb. And they invented a FARO arm for measuring purposes, but it was developed mainly for the medical industry back in that time. Around about the late 80s, the focus shifted towards the industrial market, and in 1998 they acquired a company called CATS, which was a software development company based in Germany. So that was the first subsidiary from the American roots of FARO back in the 80s. In 2002 they acquired Spatial Metrics Corp, or otherwise known as SMX, which is now the main bulk of our laser tracker division, and a lot of the team from SMX joined FARO back in the early 2000s and are still with us even today. And then in 2005 another technology was acquired from a company known as IQvolution, and that was a large volume laser scanning system which allows us to measure large buildings and facilities, for instance. And today we are the world leader in computer-aided measurement machines and software also. So you're never far from FARO, wherever you are in the world. To give you an idea there, we've got somewhere in the region of about 1,000 employees, and major offices in Florida, in Germany and in Singapore, and we have remote support offices and sales offices based in the major countries throughout the Europe, American and Asia Pacific regions. So onto the FARO product lines then. If we start on the top left-hand side of the screen, you'll see the FARO Prime arm, which is a 6-axis measuring arm. It's the most accurate measuring articulated arm that FARO provide. It comes in a range of sizes, typically a 1.85 meter or 3.7 total working volume, and an accuracy of 19 microns. The next arm you see there is the FARO Edge, which has a touchscreen display mounted at the base of the unit as well. So it means that we can actually run that arm without the need of having a computer attached to the arm. So we can run basic measurements just with the arm, no laptop or anything else needed, and completely running on battery as well, which makes it a very portable and efficient way of going to a job to take some measurements. And again, a 3.7 meter maximum working volume and a 24 micron accuracy. And the next system there, the FARO Fusion, it's a lower accuracy type of arm, more aimed at less accurate measurements, for instance fabrications and castings if you like, and up to a 3.7 meter working volume again, and accuracies of 36 microns. We then move on to the FARO gauge, which is a smaller version of the FARO arms, so it's like the little brother of the prime edge and fusion if you like. Accuracies of 18 microns and a working volume of 1.2 meters. That arm is particularly designed to replace conventional table or bench inspection equipment such as micrometers, verniers and height gauges. It is a 3D measuring system, so it comprises all of those measurement tools all in one instrument, hence the name, the gauge. We move on then to the laser trackers, which we'll be talking about. The laser tracker Ion, you'll see just to the right of the figure in the middle of the screen, is the previous generation of laser tracker that FARO provided, and we had accuracies of 98 microns at 10 meters with a maximum range of 110 meters. And then the main focus of the presentation today is the Laser Tracker Vantage, which you can see in the top right. Again, it's the same accuracy as the Laser Tracker Ion, but significantly bigger in its measurement range capability, and also significantly smaller in terms of the package itself, so a much smaller, more portable instrument, which we'll talk about in more detail shortly. And then next to that you have the FARO Scanner Focus 3D, which is the large volume system which we said about earlier, which is acquisition from IQvolution. And this system is designed to measure, for instance, plant facilities, car production line layouts, if you like, anything from sort of heritage to accident and forensic scenes as well, and also up to very large volumes of 200 plus meters. So just while we're on this slide, I'd like to just open a quick poll question out to the audience. And the question is, if you are using any of the FARO devices, what devices are you currently using? So you should have an option on your screen there to tick if you are using any of our equipment currently. So if you can have a quick tick, and then we'll get back on with it after. Thanks. Okay, thanks to everybody. And we also have just another question just related to the type of equipment that you use. If you're not actually using any type of FARO equipment at this moment in your applications or your facilities, we were interested if you use any other type of inspection equipment as well, so such as coordinate measure machines or any other type of portable equipment, or whether you're just using hand tools or inspection gauges or any others as well. So if you'd like to just answer that one as well. Okay, thank you very much to everybody for the feedback there. That's much appreciated. Okay, so we'll move on now to talk a little bit in more detail about the Laser Tracker Vantage. So, for those of you who might not be familiar with laser trackers, the laser tracker is a 3D portable measuring device. So, if you are familiar with the likes of coordinate measure machines, a laser tracker falls within that category, but it's actually a portable coordinate measure machine. So, instead of us taking the part or the vehicle or the body to the inspection area to be measured, we take the laser tracker to the part where it's being manufactured or where it is in situ. So with an extremely portable device such as a laser tracker, it means that we don't have to worry about the costs and logistics of moving things around a factory. We can just simply take our inspection equipment to the part and measure it where we make it. So it works by using two angular encoders, one in the horizontal and one in the vertical axis, and a distance measurement is captured using a laser, and the operator will move a reflector around, which is known as an SMR, and the laser tracker simply tracks where you go with the reflector, and it measures the distance of the laser beam and the two angles in the head, and those 3 bits of information can give you an XYZ coordinate in space, which allow you then to calculate distances between features and objects, or angles and everything in between, and also compare back to CAD models using the relevant softwares. So FARO have 2 laser trackers. As we said earlier, we've got the FARO Laser Tracker Vantage, which is the new one on the left-hand side of the screen, and the predecessor was the Laser Tracker Ion. So we have a significantly larger measurement range with the Laser Tracker Vantage, and also a much more lighter weight and more portable instrument to be able to move around from facility to facility using the Vantage. Both systems are compatible with our own software, which is Cam2 Measure 10, which is a FARO internally developed software to complement all of our hardware. Equally, we do open our equipment out to third-party software, so if we have users that might be using a different type of measurement software, such as Delcam or Metrologic or anything along those lines, we are completely open architecture on our hardware, meaning that we can minimize the amount of training or relearning or reinventing of the wheel, if you like, when you introduce yourselves into new measurement hardware. So some of the key benefits on the laser tracker. Then we have the IP52 rating, which allows us to measure in very harsh conditions. We can actually have very dusty environments or very damp and moist environments as well, and we can measure jobs very easily within those environments now using having the IP rating. But also, as with the previous laser tracker, we have the integrated weather station on the system, so it always means that the tracker is constantly monitoring temperature and pressure and humidity, and it optimizes itself to compensate and cope with the changes in the environment. So again, just a note there. Just a note actually on the IP rating. The 52 is actually an IP rating breaks down into 2 things. It's a dust resistance and a water resistance. So the 5 indicated in the IP52 means that we've got a dust rating where small dust particles can get into the system, but they won't cause any performance issues within the system itself. And the 2 on the 52 relates to the water rating on the instrument, meaning that with a category of 2, you can have water falling onto the instrument from an angle of sort of vertical to 15 degrees on it. So a lot worse conditions than what you'd want to be stuck measuring in, that's for sure. And also the operating temperature range has continued on the Vantage, so we can still measure in extremely high and extremely cold temperatures, from -15 up to anything up to 50 degrees C. So we can also, with the Vantage, we have a greater flexibility on the way we can approach a measurement. Because the unit's smaller, more portable, it means that we can easily get it around and quickly set it up to get measurements captured in the minimum, causing the minimum amount of downtime or disruption to a production process. And also easily move between sites using the backpacks and the roller bags that we have available now with the Vantage. So you can see there just an illustration to give you an idea of the size of the instrument, and also its weight. Just weighing about 12.5 kilos makes it an extremely portable and lightweight laser tracker, but it also gives it enough rigidity as well within that weight to make sure that it's stable to maintain high accuracy measurements whenever a measurement task is being carried out. So another change that we made within the laser tracker was to increase the measurement range. We changed the optics system to make it an inline system. So where the laser actually being delivered from is now an inline delivery method rather than a fiber optic, which it used to be in the laser tracker Ion. And it means that we can measure larger objects from one location, meaning that we don't have to move around as much as we used to with the previous versions of laser tracker. And also a new feature with the Vantage is that we have a SmartFind technology on the system. So The SmartFind allows the user to gesture a reflector and the laser tracker will come and lock onto it. So it means that we don't have to be tracking 100% of the time. Whereas before, if you had an interruption in the beam, like somebody walking through it or an obstacle got in the way of you taking your measurements, you used to have to go back with the reflector, find the beam again and navigate your way through the obstacle. With SmartFind technology, it means that we can simply go to where we want to measure and gesture to the Vantage tracker head, and it will come and find us. So it makes it much more easier and more versatile for measuring in complex and busy areas such as production lines or areas with a lot of robots and guarding and fencing around you, if you like. So improved efficiency, we have a 45% longer range compared to the ion laser tracker. And a sort of example there of how you would gesture the laser tracker to come and find a reflector using a SmartFind gesture there. So the vertical envelope for the tracker, 130 degrees, which is an improvement on the previous laser tracker ion, and also its infinite rotation in its vertical axis as well as its horizontal. So there's no end stops to find that you might track to an end stop and it binds up and you have to basically walk around the opposite direction to get to where you want to measure. So it makes it very easy for the operator to measure out wherever he puts the laser tracker. It can be mounted horizontally as well as upside down as well, meaning that we can minimize the amount of disruption on the floor or minimize the footprint that's down on the ground. So we can simply mount it anywhere that we need to, providing it's a stable location wherever we choose to mount. So this is all of the new features within the Vantage. Just at a quick glance, but we're going to go into a bit more detail of them all through the next slides. So we've already talked about the IP rating and SmartFind. We've got MultiView cameras, and I'll give you some examples of what they might be used for in automotive. TruADM, that's the distance measuring capability of the laser tracker. Integrated wireless now, so less cables for the operators to have to set up. And the quick comp measurement routine, which ensures that we can maintain the highest accuracies regardless of any environment conditions that we measure within. So we've already talked about the IP rating, and the SmartFind, as we said, was just a quick gesture to be able to move the reflector just in like a little movement in the hand, and the tracker comes and finds you. So it means that you can avoid having to navigate through busy and difficult areas with the SMR constantly tracking. The MultiView cameras that we have is a patent-pending integrated camera system, which allows us to actually bring up on our computer screen a visual of what the laser tracker can see. And if we have a series of reflectors in an area, for instance, if we're doing a repeatability study, and we have several reflectors glued onto a moving part or a part that will be moving, we can then, from the comfort and ease of sitting behind the laptop screen, we can tell the tracker that the reflectors are in the field of view. That's what we want to measure. It will lock onto them, take a measurement, and then we move to the next one and we survey them all once, and then we get the robot or the moving part to execute its move, and then come back and we can verify whether it's repeating or whether there's a shift in its repeatability when it executes a command. So also the TruADM, which is a patented 5th generation ADM from FARO, provides really high accuracy for the inline distance measurements. So we can maintain extremely high accuracies when we're talking measurements over much larger distances than what we used to be able to achieve. So we can measure up to 80 meters now radially with extremely high accuracies using the TruADM technology. The integrated wireless LAN means that we can measure anywhere, and also means that we don't get stuck with cables having to be connected everywhere. So if we have a laser tracker set up, we can simply then connect our laptop to it using a wireless capability, and it just means that there's one less cable to worry about. And if you are working over larger distances, you can actually take your laptop with you under your arm, for instance, and moving away from the laser tracker, you can take some measurements on a part which is further away than what you might have been with just a cable connection. also the quick comp capability is just a means of being able to accurately, or to get the tracker measuring accurately in any environment and any environment conditions and circumstances in a very quick method. It's completely an automated routine. It's just a one-button click on the computer, and then follow a couple of prompts on the screen, and the tracker then is optimized to work extremely accurately in whatever conditions it's been set up in on the day. So this is just an example of the transportation now of the laser tracker. For anybody that has used laser trackers in the past, you might be familiar with larger trolleys and cabinets and large sort of portable boxes or shipping cases that we used to move laser trackers around in. But these days now, it's simply a backpack and a roller wheel, like a roller suitcase, and that's all there is to it. And that's actually that's got everything that you would need to do your measurements in. Apart from a tripod, but you've got all of the controller units, the cabling, and reflectors and tooling kit all within that within those two bags, and the ones on the right hand side on the backpack and on the floor there. So this next slide gives you just an example of the accuracies that you can achieve with the Laser Tracker Vantage. Starting at a range of 2 meters. However, the laser tracker will measure up to a range of 0, so there is no drop-off at the start of the range. We can measure anything right up to the laser tracker and all the way out to 80 meters. And that just gives you an example of the maximum, or the MPE, which is the maximum permissible error. So that's the value or the accuracy that the tracker will not exceed. So any measurements that you take at, let's pick 5 meters, for instance, on the horizontal scale, is an MPE of 64, meaning that the tracker will not exceed that accuracy when it's taking its measurements. So it will always be better than that value at that particular distance. So for the text sheets and for any further sort of detailed information that I might not have covered during the presentation, you can pick up any of that information at faro.com/laser tracker. And also we have some videos demonstrating the laser tracker actually in use, which are available on the same website there, faro.com/laser tracker/videos. So here we just have some example sort of setup images just to show you how it would look when it's set up. An extremely small footprint that it actually takes on a shop floor. It's only about 1 meter in diameter that it actually would take. So it's not a big hefty CMM or anything that takes up a lot of footprint. This is an extremely unintrusive way of taking measurements wherever you need to take them. So with the tracker, with any type of tracker, we have to have laser tracker targets as well. These are known as SMRs, or spherically mounted retroreflectors. And FARO provide these in 3 different sizes and in 3 different models as well as base models. So we have the standard accuracy reflectors, which are black ring, or what we would call the black ring reflectors. Our long-range ones, which have a green ring on them, and our high-performance reflectors, which have a blue ring on them. So the difference being, the standard black ring reflectors have a centering accuracy of 7 microns. Our long-range reflectors give you the ability to measure up over the 60 meters and up to 80 meters radially. So it means that you can cover the 160 meter diameter that the tracker can measure. And the high-performance reflectors have a centering accuracy of 2 microns on the center of the reflected point within the SMR. So it means that you've got an extremely accurate means of taking measurements when you take the reflector to the object to be measured. And we also have break-resistant windowed SMRs as well. Now these allow us to measure in harsh and dirty environments, for instance, where there might be a lot of dust or a lot of moisture in the air, which could affect the optical surfaces of the SMRs. So we have a patented window that we can put across the front of them, which allows us to take measurements even in harsher conditions as well. And still maintaining measurements on the harsh environments, we have heavy-duty brake-resistant reflectors as well. They're actually manufactured from a solid stainless steel ball, and the coatings are then added onto the internals of those faces that are machined out. So what that allows us to do is have an extremely durable and very, very brake-resistant reflector. So if it gets dropped or it's knocked around a lot with the measurements, then it does survive quite well. It is a very durable type of reflector. The glass panel ones in the middle, we have those as more of a traditional type of reflector. That's more the ones that laser trackers originally started with all the years back. And the repeatability targets, just a basic open air corner cube. And what we can do with those is set them and glue them down into an object or a moving part, and like we said earlier, we can check for repeatability of that part by measuring them once, allowing the object to move, and then it should come back to its same position, and we can revalue it to look for repeatability. So it might be, for example, a robot that runs a program and has to stop in a specific location as part of its process, so we can monitor that. It might be framing gates on a body and white line. It could be a door opening and closing on a car, for instance. So there's many different applications that you can use repeatability targets and laser trackers on within the automotive sort of industry there. We also have RetroProbes and target tooling kits, which allow us to get measurements in smaller and tighter to reach areas, for instance. As all of the reflectors, the SMRs, have standard sizes of 1.5 inch, 7/8, and 1/2 inch. So they are larger than, say, for instance, a 6mm hole, as an example. So what we can use is RetroProbes, which have 3mm and 6mm tips, as an example. And also we can use the target tooling kits, which have various already ground-sized adapters that will allow us to simply insert the reflector into a hole, like a 6mm or an 8mm hole or anything like that. So we have a range of tooling which allows us to do that as well. And again, we have some more information on the laser tracker targets and accessories, and that's all available at faro.com/laser tracker. So with any type of measuring equipment, you also will need, or normally will need, a measurement software to complement the system. So as we said earlier, CAM2 Measure 10 is a FARO internally developed software, and it allows us to connect either our FARO arms or our laser trackers or our scanners and run them all from within one measurement software package. And it gives us, some good features like easy move wizards, so we can move the devices around very easily. We can set up remote measurements. We can easily repeat a part measurements. If you have 10 components or however many, once you've measured one, that measurement becomes the template for the next number of next number of components that you have, meaning that you can simply clear your readings and remeasure the part again and again, and the nominals will already be set, and your tolerances will always be set as well. So some examples there of some of the screenshots taken from CAM2 Measure 10. In the top left, we've got the scanning capability, which allows you to sort of generate a point cloud on the component. In that case, the component's being checked back to a CAD nominal model, and the actual physical part was compared and aligned first of all, and then compared back to the CAD model. And on the top right hand side, it's just an example of some of the geometrical measurements that you can capture. So it measures all 2D and 3D objects within the measurement space. And the reports at the bottom, very easy to generate. It's not a labor intensive process. It's simply a case of dragging what you want in the report into a field, and the report then populates. The nominals and tolerances are just keyed in by hand very easily, or they're loaded in from a nominal data set like a matrix or a CAD model, for instance. And then PDF or Excel reports can be generated at the click of a button from there. Well, another key benefit with the CAM2 Measure 10 software is the ability to have the Cam2 Remote available, which is free to download on the Apple App Store. And providing that you've got a wireless enabled Apple device such as an iPod Touch or an iPhone, you can install this app, and then using the wireless network on the laptop, you can connect remotely using your Apple device, and from there you can take measurements and actually view data coming back from the measurements as well. So it means that you can be measuring several meters away from the laptop and still have complete control and command of the laser tracker. So you don't have to keep running back to the computer screen to see what's going on. You've got control from wherever you're standing simply with the remote application. So we're going to talk a little bit about some applications and industries now. But before we do, I just wanted to open another poll question out to the audience, and that is just to ask what industry sectors are our audience actually working in at the moment. So it's just to find out, you know, if you're actually in automotive, in aerospace, or heavy machinery, power generation, or any other type of industry that might be that's out there. Okay, so moving on to the applications then. So we have an exemplary laser tracker application infographic here. So in this case, it's an aircraft as an example, but this could equally be a car production line or a large factory or facility. It's just to demonstrate the sort of size of what we can actually achieve and measure with a laser tracker. But you know, the areas we might use it would be part inspection. So we take the laser tracker quite easily to the component to be checked, and we can check an individual piece against either a drawing or a CAD model. When we look at assemblies, we can check that components will go together, even if they're built remotely from each other. For example, you know, an aircraft being manufactured might be built in several different countries and then assembled on what's known as a final assembly line. So in order to verify that the parts will go together, we can actually virtually build and assemble using data collected from laser trackers even before the parts are shipped to each other to check that they will fit. One of the big applications also is robot calibration. So because our laser tracker Vantage is able to dynamically measure and measure in 3D in real time, we can attach reflectors onto a robot and map its path and verify that it's actually following its nominal track as well. So extremely handy if you might have a line of spot welds that aren't actually in the right place or anything along those lines. So it means that we can verify the path of the robot. Machining fixtures or tooling fixtures, if you like, as well. So body in white, for instance, you might have several tools that have nominal pin positions or holding clamps, and they need to be verified to ensure that they're in the right place, and we can do that just by checking the fixtures, again using laser tracker and either a CAD model or just nominals from a drawing. And then also just general quality control. So all the data that's captured on the laser tracker, it can be used and exported and put into SPC data, meaning that we can actually, you know, look at the quality control as well and maintain our systems to their utmost levels as well. So some example applications that we might use a laser tracker in. Installation would be one of them. So we have a part that needs to be put into the right place within a facility, or it needs to be installed correctly to another part, and we can use the laser tracker using the DRO windows, the digital readouts, which are the green numbers you'll see on the screen there. So that's data that would be coming from the laser tracker. When you have it on the screen, once it's green and it's in the right place and it turns green, you know that your part's correctly positioned and installed in the right place. So as we just mentioned there, robot calibration is another big area that we can use laser trackers within. If you have, for instance, a car production line that's built using or designed using a virtual assembly, you can actually take the robots and position them where they need to be in relation to the tooling, and then upload the program into the robot, and with a minor amount of adjustments, the robot should be running in the right place without having to teach it by hand or pendant teach it, which is a time-consuming process to do. So general inspection and quality control, it could be anything from fabrications to high precision components, and in any industries as well, as we'll cover later on. So again, quality control, it's very easy just to take your measurements and then simply upload them onto or generate a report using a one-click command, and then upload that data into your networks so that it's available for all of your customers or your suppliers or your internal people to actually see the data almost real time as it's measured and completed. So another area that we can use laser trackers in is reverse engineering. So if we haven't got drawings or we haven't got a CAD model of a part, we can use laser trackers, we can use FARO arms and laser scanners, for instance, to digitize the physical part and then reverse engineer and remodel or generate a CAD model or a drawing based on the physical measurements that have been taken. So it might be that you've got older plant or equipment that hasn't got a drawing or has been in for a long time, and it hasn't got any sort of data, or it's all changed and it's moved and deformed, and we can actually, if it does the job and it works, we can remodel that and treat that as a new nominal, if you like. So some of the industries that we work heavily within as well, we've got aerospace. We work with the likes of Airbus, Boeing, Bombardier, and all the major manufacturers of aircraft and airframes, and along the lines as well, anything from the wings productions to the fuselages and the final assembly lines as well. And laser trackers are used in a variety of different ways within the aerospace industry there. And automotive, we use the trackers everywhere from body in white, so it's tooling installations, production line sort of setups, robot installations and calibration, all the way down to the finished vehicles, or even through to the body in white first, and then the finished vehicles at the end of the line. We've used them for crash test analysis, and also even the Formula One teams, where they demand much higher tolerances and accuracies. We're able to meet those requirements using the accuracies within the laser trackers as well. So power generation is another industry we work quite closely with. It's anything from hydro to wind turbines to coal and nuclear. They all run on similar principles. There's a generator which turns the turbine, it generates electricity, and we can during outages we can verify that the turbines or the housings are correct, and that the parts are going to go back in correctly. And there's various other applications that we can do within the power industry as well. And then the boat and shipbuilding industries, anything from the fiberglass to the GRP type molds, and all the way up to the heavy steel fabricated ships that you might see, like the oil tankers and the aircraft carriers and the Type 45 destroyers, anything along those lines. So from the very small to the very large, again, if you've got CAD or you've got drawings, the laser tracker has the measurement range and the accuracy to meet the requirements within this industry. And then machined parts, so this might be a jig or a fixture or tooling, for instance, or just a component that's been on a machine, on a CNC machine, for an example. And you can see some of the size and the complexity of some of those parts. It's not an ideal situation to have to move those parts around to take them to an inspection area. So when you have a laser tracker, it makes it extremely easy and efficient to take the measurement device to the part. And it's much easier for us to move a laser tracker than it might be to move something along the sizes that you can see on the examples there. And the government and military also use the equipment for various measurements of components, anything from aircraft to submarines to land-based defense vehicles. Anything. It's still a manufactured part. It still requires measuring and verifying. So the equipment again is used heavily within these industries as well. So just to give you an idea of some of the ways that we can, some of the mounts and some of the accessories that we use with the tracker, we've also already talked about the different types of targets and the target tooling kits. But you've got in the top left the types of stands, and we can mount them on portable tripods, which are extremely easy to move around. We've got more heavy-duty rolling stands, which is designed to be in a shop floor area and on a flat surface, ideally. We have magnetic mounts, vacuum mounts, so there's a lot of different options there to actually get your laser tracker or your FARO device in situ. The other benefit is that they're also all of them are universal, so the mounting option is regardless of whether you've got a FARO arm or a FARO laser tracker, we can mount either of the devices onto the same stand, meaning that you don't have to have a whole new set of accessories for one of your instruments and then have to get another whole lot of accessories for the next instrument. So that's a small example of a small snippet of some of the major companies that we work with. We have 20,000 installations worldwide, so it's usually that we know of most of the major companies, and we're actually working closely with them already. So just some example quotes and testimonies from some of our existing customers that are using the measurement equipment. You've got a lot of large industry powerhouses there as well: Oceaneering, Machine Concepts, Marine Concepts, and just a small example again of some of the customers and how they're using and how they got by with how they're getting by with our equipment as well. So for any further information on the laser tracker or any of the FARO equipment, it's faro.com, and for the laser tracker it's just /laser tracker. So that's it for me now, and at this moment I would like to thank everybody for your attention, and we'll now open up to a Q&A session, and I'll be happy to answer any questions that you might have arising from the presentation. So thank you.
Thanks, Keith, for that presentation on the laser tracker system. We do have some questions from our attendees. First question here is: what changes or improvements have you made to the MCU?
To the MCU, I would say that the wireless capability is one of the most significant changes to the control unit. It used to be that I had to be connected via a wired Ethernet cable, but now we have the option of going wired or wireless depending on the circumstances on the site. We haven't gone exclusively with wireless because we are aware that you have certain security policies and various restrictions on certain sites. So we've given the option to our users and our customers that they can choose one or the other using that. I think based on the ION, there's probably not a lot of difference in terms of size. I mean, the controller unit is just the brains of the instrument, and the interconnecting device, or the area where it communicates to and from the tracker head and the computer. So apart from that, I don't think there's many new changes surrounding the MCU actually.
Okay, thank you, Keith. We have another question here. Why use two cameras? It's with two cameras based side to side to each other. It gives the tracker the ability to see in 3D, so it gives it a depth of field
on that one. So I'm not too sure on the exact science behind it, but that's probably about as best as I can answer that at the moment, I'm afraid.
Thanks, Keith. We have a question here, and we have a couple of questions relating to this, I think. Does the tracker transmit video images?
It doesn't transmit them live, but using the MultiView cameras, you do have an option within the software that you can activate a window that shows you what the tracker is actually looking at the time. So it's just a grayscale image, just a black and white, that shows you what the tracker actually sees. And if you've got a reflector in that field of view, it is actually being pulsed with a light that allows it to shine very, very reflectively within the field of view, and that allows you then to simply click on the reflector when you see it in the field of view, and the tracker will head over to it using the SmartFind technology. It will lock onto the reflector and allow you to carry on taking measurements.
Yeah, I think you may have mentioned this during the presentation, Keith. The question is, does the tracker have its own power supply, or is it necessarily, do you need an external supply?
We need an external supply due to the type of motors and that we use on the tracker. So it is an external supply, which is either 110 or 240 volts through the domestic supplies. So you can connect it to a factory floor if you've only got 110, or you can run it in the offices on 240 as well. So we can run on either.
And a similar question, really, in the same vein. I mean, is it possible to use it with any kind of battery pack?
Not as it is at the moment. No, we have to run it on a mains supply at the moment. You can connect it to UPS systems like uninterruptible power supplies, but they're quite heavy and bulky to move around, and also you have a limited amount of life within those. So for the majority of it, if you're doing measurements, it is mainly on mains supply.
We've got a couple of questions here, actually. Just, I think, again, you may have mentioned it during the presentation. Are there any videos showing demonstrations using the laser scanner or the SmartFind?
All of our media at the moment is all available through the webs through the microsite on our website, which is faro.com/laser tracker. There is a video section there which does show all of the videos of applications and case studies, and also some more further information on the SmartFind, and everything is available through there. So I think there is one there, yes.
We've got a quick question regarding the accuracy or the changes that have been made from the ION to the new tracker, to the Vantage. It says, how come the accuracy of the tracker has changed from 0.049 to 0.098 within 10 meters?
Okay, the accuracy hasn't actually changed. The way that we express the accuracy has changed on our text sheets. What we used to quote was what we would call typical MPE, which is half of the MPE value, the maximum permissible error. But to bring our text sheets in line with the sort of, there's not actually an industry standard, but to make it easier for our customers to understand if they're looking at different systems side by side, we decided to change to just showing the MPE values only on the text sheets. So it's the same accuracy, it's just expressed in a different way. And I think we are changing to back to the half and the typical and full MPE values on our text sheets soon in the future. So you will see the 49 at 10 meters again on the text sheets in the not too distant future.
A few more questions here, Keith. I'm not quite sure if this one's, if I'm reading this one correctly. Does the tracker have a controller? You mentioned controller software earlier on, didn't you, in the beginning of the presentation? Sure.
Yeah.
What the question is referring to specifically, but if you could talk a little bit about the control systems for the tracker, please.
Yeah, the tracker is it's basically two major components. One is the laser tracker head, and the other is the control unit, which is what we call the MCU, the master control unit. So that might be what the question's referring to, but that's a 5 kilo unit, which is the hub of where the power goes in. It's where the laser tracker head feeds data to, and it's where the laptop establishes communication to the laser tracker system from as well. So that's the 5 kilo unit. It's about the size of a toaster, if you like, to give you an idea of the size and weight of it. And the laser tracker head itself is the other major part of it, of the the system, which has a 12.5 kilo weight, and just a cable connects, one cable then connects between the control unit and the laser tracker head itself.
Thanks, Keith. We have a question here that's slightly, just slightly out of our automotive field. The question is the system approved for operative rooms in the medical field?
I don't know about specific accreditations, but we are sort of, or the instrument is CE certified, and we conform to all the general sort of national standards, the Food, Drug and Standards Agency. But if there's any specific ones, I probably need to ask a question if they had a specific accreditation or approval that they wanted, that the person questioning would like to find out about. We'd be happy to sort of answer it via an email or something like that later on.
Thanks, Keith. We have a question here asking you regarding the price and the lead times, information on for the laser tracker. Keith, can you offer some information on that?
Well, typically lead times are 6 weeks for delivery. Price, it would depend quite significantly on the type of software, accessories, and the model that you choose to go with. So price is a difficult one to answer in a broad spectrum like that. But we do what we do offer is that if there is a party interested in a system, we would send one of our specialists over to the site. We'd sit down and have a consultation with the customer or the client, and we would tailor a solution specific to their requirements, and we'd be able to give an accurate price and costing based on that.
Well, thanks very much, Keith. A lot of very interesting questions there, a lot of interest in the laser tracker. We're now going to conclude our webinar for today. Thank you very much for all our attendees for joining us. The webinar will be uploaded to our archive and is accessible in the future for all your colleagues who may have been unable to attend this live presentation. You can access this and any previous webinar under the Process tab on the AMS homepage. Thanks again for joining us today, and we hope you'll join us for our next webinar. Thanks very much.